Hello everyone, welcome back to the radio shop and a new series on resurrecting some dead. And what we have here on the bench is a Heathkit Apache. This is the model TX-1, and what this is a 10 through 80 meter CW and AM transmitter, also known as the Scratchy Apache, and we'll get more into why they call it that later on in this series of videos. But I've been wanting to get back in AM for quite a while and just have not found a piece of equipment that was good enough for me to try. So I do happen to have two of these Apaches, and I think this one is probably in better shape electrically, while the other one is probably in better shape cosmetically. But still, this one is not too bad. It mostly just needs a good cleaning and a little bit of paint here and there, and I think it would look pretty good. But what you see here is 107 pounds of radio. I had to place this piece of plywood here. It's about 28 by 28, half-inch thick, over top of my workbench, because I use on the new workbenches, these are door cores, and they're just blank door cores that's never been drilled out or hinged. And you know, they only have about a 3/16 of an inch veneer on top of them. Pretty suitable for about anything but this old heavy equipment. So I placed this piece of plywood up just to keep from punching through the veneer on the door. But it's supported by salt treated 2x4, so it'll hold it. Like I said, I do have two of them, and it's just no way I was going to put 214 pounds of radio up here on the bench. I may find it in the floor later on. So this will probably be several segments of video. I'll be working on this in my spare time, trying to get it back up and running. And at the moment, it's already been brought up on a variac and checked out to find out what it wasn't and was doing. And it's interesting to see how these old things are constructed. But we'll be going through it and see if we can get it back up and going. Well, I have only worked on a few of these in my lifetime. Like I say, I do own two. I did have another one, I sold it and kept one that I was going to use for parts, and then I picked this one up. I showed this in a video a while back on future projects coming up, and I got something in the mail. I've already added it to a mail time video, so we'll be getting into more of that later on in another segment. Usually what I try to do, I'll get several items, and as they come in, I'll go ahead and video it and put it in a storage folder on the computer, and then when I get enough, I'll do a mail time video. But what sparked my interest to go ahead and get this up? Well, before I go there, let me say, as I said, the Apache TX-1 is a CW and AM transmitter. Although if you look on the mode select, you'll see single sideband. The Apache does not do single sideband on its own. You have to have an adapter. And if you look here beside it, we do have the SB-10 single sideband adapter. And this gives you single sideband coverage 10 through 80 meters to go along with your Apache. And it has provisions in the back to wire it in, and as you can see, this one is in excellent condition. In fact, I still got the bubble wrap on it. I haven't took it off yet, so I'll let it stay on there. But I mean, you just look at it and it is just in great shape. I haven't even taken it apart to see how the inside looks, but if the inside is anything like the outside, I don't think there'll be too much problems at all getting it all back up and going. But the biggest thing is getting the TX-1 back up and running. Now I will tell you there's some heavy iron in this thing. There's, I think, a total of 6 transformers in here of various states. And I have to tell you, if you're playing along at home, you are doing so at your own risk. There are lethal voltages inside this unit, and it can kill you. So if you're doing so, do it safely. So I'll go ahead and tell you, I am no expert or guru on the TX-1. This is kind of stepping out on new waters, but the same basic principles apply. So you'll get to see me go along and see my thought process on how to go through this and get in my head a little bit to find out what I'm thinking. But as always, the first thing that you do is give everything a good visual inspection and see what's going on with it, from a visual standpoint. And one of the first problems we can see that we are on the 20-meter band. And when we look at the dial, we're looking straight on. The first problem I see is that I can't read what band I'm on. And it's not that anything's broken, it's just out of adjustment. If I reach over here and grab this dial string and give it just a little push, you can now see that the 14 megahertz band spread is up. When I release it, it goes back down. So as you can see, the way this works, we have a roller that has all the printing on it for the bands. On the other end is a big spring that makes the roller want to turn one way. So there's only one dial cord that comes up from the band select, and it wraps around a pulley here on the end, and it pulls, and when you turn it back, it releases. So the spring tension is what rolls it back around. So this dial cord, see if you can see it right here, is where this tension is put on to pull on the spring. You can see I can rotate it, and when I do, you can see the drum turn. So all we got to do is just adjust that dial cord just a little bit to get it back on alignment to where it needs to be. So there's no big deal there. Anyway, just looking at the end, you can see all VFO. Everything is inside this metal can, with the exception of the tube. And what this does, that keeps all the heat out of the circuit. Tube's on top, and then it's directly coupled right inside, so that keeps all the heat out of the can for our VFO. And the VFO runs around 7 megahertz in this unit. We can see here, this is big piece of iron here is our modulation transformer. We have a pair of EL34s. Over here on this end we have a rectifier tube. This is our power transformer. The big one here in the middle, which is the same size as the power transformer, is a choke. And then over here on the end we have a plate transformer. So the plate transformer is separate than the standard power transformer. And you can see the big cage over here with the fan on top. This is our PA section, and it uses a pair of 6146s. Then hiding over here on the end is a couple of I think they are 5R 4GY rectifier tubes. Along the bottom we have our SO239 as our antenna port. You can see these two SO239s here are for the single sideband adapter input and output, TR switch, a power cord, and accessory plug. So looking here under the bottom, this whole back rear compartment over here is the whole width of the unit. This is our power supply section, and as you can see, we have two big filter caps here, 120 microfarads at 450 volts. There's supposed to be another metal can here, and I believe it's a 4-section can that has been removed. And down here in the bottom, you can see someone has stuck two paper capacitors just kind of flapping around under there, and I do not know where they put the other two at. I do not see them, so I'm going to have to trace out the circuit to find out what's going on with it. Like I said though, you know, another good thing is I do have another one sitting down here with the case off of it, and you can see the 3 cans, the 2 paper wrap ones and the 4-section can there. So it's kind of easy to use that to look at to see how it was originally wired up, so when we go back to restore this one, we can get it somewhere back to like it should be. But that was not in too bad a paper. You know, I thought about using it from parts, but I might go ahead and end up fixing it also. So moving right along here with the sections, we got this section right here. This is our modulator section. You can see the bottom of our modulation tubes. Down here in this middle section, this is the exciter, and then just below that you'll see our mode switch and a few regulators, but they call this the final section because just over top of it is the final amplifier section. Now the unit does have a few mechanical levers and gadgets in here. It's kind of a engineering dream here is the way this thing is made. You can see these fingers in here, and when you rotate the band switch, you can see those fingers will move the other switch along. Kind of real neat how they done that. Also in this O here on the side, you can see there's several gears and, well, not gears, but shafts with linkages here and there. We can see down here there's some metal bands that rotate other capacitors and stuff inside. And we have another one here. Let's see, that's on the drive circuit. And you can see that one turns the shaft and moves this variable capacitor. Or as Paul says, potato chopper, which is just a very small one, so if you want small potatoes, that's be fine. But yeah, it's going to be quite a bit of work here, and what we'll just have to do is just take off and go through each section at a time. Probably start, you know, with the power supply, because if you ain't got your power supply right, ain't nothing else going to perform correctly. So, you know, quite a bit of extensive work inside the power supply itself to get into it. So like I said, this unit has already been brought up on a variac, and no problems whatsoever. It's not drawing excessive current. There's no shorts in the capacitors, and the capacitors seem to be pretty healthy in the state that they are, but they will all be replaced. And like I said, we'll get all these here back out, get these old paper caps back out of it. Up here in the top, there's a couple electrolytics and a paper cap here that's got to go. And there's 1 or 2 more in the circuit. There's not a whole lot of them in there, but all those have to go out, and what I'll do is end up building a board over here to go on the mount on that shelf that'll hold some new capacitors. So I just want to go ahead and power the unit up, and what we want to do is just verify a few things that are working. I always tell folks, when you're working on something, sometimes it's easier to find out what does work instead of going in and looking at what doesn't work. If you verify a circuit's working, then you know that how far along the unit is. So what I want to do here after I fire it up, I want to go in here. You can see right here in this section, you can see this little small RF choke here. On the right side of it is where our VFO input ties into it. So what we want to do is verify that we have a 7 megahertz single coming from that coax cable. Because if we don't have any signal from the VFO, then nothing else is going to start to work. So I'm going to clip on an isolated test cable and go into our frequency counter, and we'll have a look and see if we have 7 megahertz there. Alright, so we have our mini grabber connected to it, and you see there's another one here. This is direct, this one's isolated through a capacitor, and then our ground. And this is just a was made by B&K, and it's a counter input cable, so it gives you a direct and an isolated port. And I've made a few of these for other people along the way, real simple to make, and I have it plugged into the frequency counter. So I'm going to go ahead and power this up and let it warm up just a minute, and we'll go ahead and check and see if we have all 7 megahertz. When I have the unit warming up, and again, when you got these over on the side, like I said, these things are heavy and they are a bit unstable. I have a block of aluminum heatsink under one side of that transformer so it doesn't tip over. But you have to be careful standing these up on the edge, because your only contact point is going to be the front here, and then the back side of the case, and that can make it tip over. So it's always good to prop it up. If it goes to fall when you reach in and try to grab it, it may be shame on you. Okay, had to find my frequency counter. And this is the B&K 1803 that Mike sent in a while back. And as you can see, it just random counts until it sees a single. So that's not none of the problems there. Sorry about that glare on it. Let's see if we can get that glare off. And my throat is a little scratchy today, if you have not noticed it or not. The only thing we're going to do is going to put this in the tune mode. Wrong button. And we're on 20 meters. And all I'm going to do is hit the spotting button. I have a problem talking today too. And we should get a 7 megahertz single. And there we go, 7.190. And if we rotate the VFO, we'll see it change. It was at the far end. And we'll rotate it right on through. And it went all the way down to 7.013. So that shows our VFO is working. Very good sign. You know that the front end part of the exciter is activating. So just to run that little test, we have put the operate on tune switch in the tune position. We left it in standby, not transmit. You know, this doesn't have a PTT on the microphone. You have a switch that you flip to transmit. And we just left everything else pretty much centered throughout, and we're on the AM mode. And to get our reading, we just depressed the spotting button, and that showed us we was on. Our VFO was putting out 7 megahertz. Now if anything else is mixing in with it, I'm not sure, you know. I do have it on high voltage here on our meter switch, so we'll go and look and see if there's any high voltage at all. I'm going to do this by flipping over the transmit and get my hands out of the way. And we see our plate voltage did come up. We'll switch over to grid. And we have nothing on grid. We'll go down to our driver. And again, nothing. No reflection from the meter. So the only thing that seems to be working at the moment is our VFO. And there's nothing else, no other signal that looks like, you know, is being generated. Okay, I have the a receiver hooked up here, and I have this little sniffer on it, and this is insulated magnet wire. It's about 3/4 inch in diameter, and it's right on a BNC connector, as you can see, and I got several different ones I can change out for different size. When you're using these, do not put this inside of a circuit, because this is all metal and you can get a nasty shot. But just, you know, checking out different things, this is fine to do. So all I'm going to do is just lay this here by the radio, not touching nothing. And it wants to touch the chassis. But anyway, what I'm going to do, we know our VFO is working, and just to verify that, I've got the receiver tuned to 7.160, and we'll push the spark button. And we can see our radio is, our receiver is hearing that signal, and that's pretty good and strong, even though when I move it away, it still hears it. So the VFO's got a real strong signal. Now all I'm going to do is just tune it to 14.250. Watch where I stick my fingers. I'll bring this dial back up and tune it right on 14.250, and I'll turn the receiver over to the 20 meter band and dial up about 14.250. There's a birdie in here. No idea what's putting that out, but it's pretty strong. That receiver's on 14.250. I'm going to put it into transmit mode. Moving the VFO back and forth. Absolutely nothing coming from the exciter. Oh, yes it is. Okay, the dial's about 25 kilocycles off. So it sounds like our mixing scheme is working also. So we verify that the VFO is working. Now we verify that our mixer circuit is working. Like I say, it's about 25 kilocycles off, but that's okay. We can get that tuned back up. Alright, we know that our 20 meter band is putting out a signal. I've switched over to 15 meters, and we'll go in. I've got the radio receiver on 15. We'll go in here and we'll tune across right quick. Alright, we definitely have exciter working on the 15 meter band. We'll move on up to 40 meters. And there's our 40 meter band. And we're still connected to the frequency counter, and we're getting a VFO frequency of 7.216, and the dial is on 7.2, about 223. Okay, we'll go ahead and check the 80 meter band. Very strong signal on 80 meters, and our VFO is rating 3.7 megahertz. That may be reading direct. Okay, so the only band we haven't tested was the 10 meter band. We'll go ahead and fire that up. And we have exciter power on our 10 meter band also. Well, okay, now we sort of kind of know where we're at on this radio. We know what's working. We know there's no power out, there's no grid, no drive that we can see on our meter. Our meter does work because it shows on the high voltage scale, but it still could be something else causing, you know, the power not to reach through. Even though over here on this side of the bench I do have that old cheap power scanner meter over here. I've got to get me another good RF watt meter to go on this side of the bench. Maybe one day I'll pick up a bird or something if I can find that a good price, or just any good power meter to go over here. It needs to be a vintage meter, because that's what this bench is all about, with the all the vintage equipment over here. So I need a good vintage power meter to put on the side of the bench. But anyway, looks like this is going to be a lot of fun getting into, and probably the next thing I'll do is go ahead and get some capacitors ordered and get these old capacitors replaced and start checking resistors. So we'll probably do that in the next video. And once all the resistors are checked out and the capacitors are replaced, let's see, I have a sheet of paper here somewhere. I can figure out what I did with it. And it was right under my nose. But anyway, yes, after we get all that done, then we can, you know, check the tubes, see where our tube's at. And then we've got this little chart right here that's in the manual, and it gives every tube and all the voltages that we should be seeing on the pins. So we'll go through that one tube at a time, check all these voltages and see if we're within tolerance. And, you know, I'll probably reprint this with a place to write underneath of it on the actual voltage that we're reading, and that will tell us a whole lot about what's going on. You know, and always whenever you're working on a older piece of equipment like this, just go online and download the manual for it. And the good thing, they have a pretty decent manual online for the Apache TX-1, and you'll see the huge schematic and lots of information, circuit theory and everything on it. So about everything you need you'll find right here. And since this is an assembly manual, it really gets into a lot of the details. So you know, always go in and look for stuff like this, because this will help you. And you know, you can also go on the web and search Heathkit TX-1 Apache and find all kinds of things. And you know, I suggest doing that for anything that you're working on. If you're having a specific problem, go to Google, type it in, and pretty sure that you'll find something that'll get you close, or you know, at least it leads you in the right direction. Yeah, you can find a lot of stuff that's no help whatsoever, but you know, there's a lot of help out there. You kind of got to read it and look at it and see what the authors are saying. But yes, that's always a good idea. Just go on through the manual and read through it and learn it, you know what each part is doing, why it's in there, and it'll help you get more familiarized with what you're working on and what to look for. So anyway, I know we already have several projects going on, but you know, I like variety. Work on something for a while, move on to something else, and give you time to think about your other projects and so forth, and go on from there. You know, big thanks to Chuck for sending in that single sideband adapter. That is what really got me pushed on wanting to go ahead and get this station back up and running. I need to find me another receiver. The Heathkit made a matching receiver called the Mohawk that is about the same size as this, but the receiver is not that great. It has a lot of drifting issues and so forth, so I'd like to find me another good tube receiver that's, you know, got some mass to it to go along with the Apache. So I'll be looking around and see what I can come up with that. I have several receivers, but you know, I want something of the same era and vintage. Maybe find another Heathkit tube receiver or something to go along with this one. Anyway, I'd like to hear your comments down below. If you like the video, you know, give me a thumbs up. And always interested in hearing what you have to say. And I'll put some information down below, and contact information, by clicking on the Show More tab, if you would like to follow along with this. Anyway, we'll catch you in the next video. See you now.